Hello everyone, welcome to my YouTube channel Tech Learn with Data. Today we will discuss about the difference between Apache Spark and RDD. If you have worked with Apache Spark or you have seen my video, you have probably heard of DataFrame. But what exactly are DataFrame and why are they considered the modern approach to big data processing? In this video, we will explore what are data frame, how they are different from RDD, and how to perform common operations into data frame like filtering, aggregating, joining, and more using the PySpark. By the end, you will have a solid understanding of data frame and be ready to use them in your own Spark project. So let's learning. So what is a data frame in Spark? A data frame is a distributed collection of data organized into named columns, similar to a table in a relational database or a spreadsheet. Data frame is also designed to handle structured or semi-structured data, make it easier to work with than RDD. We have some feature of the data frame. That is also used for the schema perspective. A data frame have a schema which defines the structure of the data, like it is also having a column name, or we have to define the data types like a integer, string, or what type of the data type for a particular column. Second, that we need second feature is used for the optimization related, that Spark catalyzed optimizer optimize data frame operation for better performance. We use an easy way of the data frame, that we can also provide a high level API for data manipulation, like a similar apps to SQL, or like a simple to similar to Pandas. Okay, so in the in the other scenario, that what is the RDD in Spark? In the previous videos already we have discussed what is RDD. So RDD is like a resilient distributed data set. This is a fundamental data structure of a Apache Spark. It is also a distributed collection of elements that can be processed in parallel across a cluster of machine. Okay, so what means the resilient? Resilient means that if data is lost, Spark can recompute it using lineage. Okay, like a data lineage, which is also a record of transformation. Okay, distributed data is split across multiple nodes in a cluster. Immutable means that cannot change. Okay, RDD never cannot be changed. Instead, if we need to change RDD, that we need to create a new RDD for for a different transformation. Okay, so we have some features of RDD, like RDD are the backbone of Spark because they are enable fault tolerance. Okay, and they are also support in memory processing. Okay, that can also from the in memory processing, they also making Spark much faster than disk based system like Hadoop MapReduce. Okay, it also allow parallel processing of data across in a cluster. Now we have to look that what is the main difference between RDD and the data frame. Okay, like if we discuss about the structure, RDD follow the unstructured and no schema data set. Okay, and whereas the data frame is also follow the structured schema, that is also having the name that, and also the define, we have to define the data type. Come into the optimization, RDD built on the no built-in optimization, but data frame is also optimized by Catalyst Optimizer. Okay, easy of use. That RDD, that's a low-level API, harder to use, that we can use, but instead of data frame, it's also a high-level API, and we can also easier to use. If we talk about the performance, RDD is slower for the structured data, but data frame is also faster for structured data. Use case, uh, it's also for the low level data processing, like small data size, but data frame also is for the structured data analysis. Okay, in short, we can say data frame are more user friendly, optimized for structured data, but RDD are more flexible for the low level processing. Okay, so these are the key difference between RDD and the data frame. To a code. Okay, like there is in a code that we have to create a data frame from a list. How can we data frame create from a CSV file? Some we are also we will perform some operation into the data frame like the select columns, filter rows, aggregating function, add a new columns, that we can perform the drop duplicate. How can we rename of a column, and how can we join between two data frames? So these we are following the these two we are basic we will do perform some basic operation into the data frame. Okay, so let's start. Let's open So let's start the Spark data frame. Okay. Now first what we do, same that we have to initialize the Spark data Spark session, like from Spark by is equal to Spark, that import Spark session, and then Spark is equal to Spark session dot builder dot app name. Okay. Just what we will do, we will create a data like data. What we will do, that we will define this one name in age for the most like the Alice, Bob, Catherine, David, and Ella. Okay. What we will do, second one, that we will do column define name and age. Okay. After that we will create a data frame spark dot create data frame data comma columns. Okay. Now what we will do, df dot show. So you can see here that we, if we execute this one, that we can also get the data whatever we have defined into the data. Okay, just wait for this one. Okay, now we have got the name and age, like Alice 34, Bob 45, and the Catherine, that we are getting the name and age as per the data. Okay, second option, to create a data frame with the help of CSV. Okay, so next we will create a cell. Okay, just what we will do, just data frame is equal to spark dot read CSV file. Okay, this is the syntax. Instead of data, we have a employee CSV in our folder. Simple, we will do employee dot CSV. Okay, now df simple df dot show. Okay, so whatever data inside the employee dot CSV file, it will show the data, whole data we can see. Okay, so we can also create a data frame with the manual data. Okay, or we can also create a data frame with the help of CSV file. Simple. Okay, now what we will do, what we will perform some operation like select, filter, duplicate, drop duplicate, rename of a column. Okay, first we will start with the select column, then we df dot select name and salary. Simple. Okay, dot show. So it will the data to you show with the name and the salary here. Okay, simple. Now what we'll do, we will perform the filter data. So just create a code. We will do df dot filter salary, whichever is greater than 400. Okay, so it will show the data who have the salary greater than 400. Okay, so now what we will do, we will also perform the aggregate function. Here what we will do, we will perform the department wise salary aggregation. Okay, so what we'll do, df dot group by dot department dot count, or that we can also sum of the first we will count of that one. Okay, simple, check that we have the sales 3 count, HR 2 count, and the finance 3 count. Okay, same we can do for the salary perspective. Okay, just we let's see. code tf dot group by dot department dot aggregate salary. What is the average age and max? Okay, age is not here. We'll do the age. So simple. So it will give the result of average of salary as per department wise. Okay. Now what we will do now needs to create a new column. Okay, like if we need to create a new column uh, like as a country for each employee. So what we will do, we have a lit function to include a new column. So just a simple thing from PySpark dot SQL dot functions. Okay, import lit. So in the next table, it will automatically come df dot with column country that lit USA. Okay, it will also include a new column country here. Simple. Now what we'll do, now come into for the union. Okay, for the union we need a new data frame here. So we need to create a new data frame like df1. Okay, and insert a new same value of anyone. That if we insert any the same value like the one li sales 500 5200 USA. So what we will do, what we will create the new df1 new data frame, and after that we will also do the union, and whatever the duplicate value, that we can also the duplicate remove the duplicates. This is the case study. Okay, so just simple new row. Okay, tf dot union new row. Okay, so just a simple just a let's see what happened. Okay, part is saying new column you can perform the input on the same number of columns. Here what we have, uh, id we have also. Okay, tf dot show. Let's see. So here you can see they also created the duplicate rows in here. Okay, Sam 40 USA HR. Okay, this one. Could we have this one? Why it has been created? TF union new row. Okay. If we do the same thing here, like if we also do the same thing again. Okay. So one more row also is there. Now we will try to drop the duplicate. Now whatever we will see, we have the duplicate rows is here. Okay, three rows are there. So what we'll do, simple df dot drop duplicates. Drop. So you can see here, here we have also delete the duplicate values. Okay, one more thing, we will create a new data frame here, which will be also a new df1. Okay, same value we will also insert into this data frame. So new df1 is here. Okay, so what we can see, what we will see, the same value will come twice, populate twice. Okay, okay, so here we have, we are able to see the same name also populating twice. Okay, again we will just execute the drop dot duplicate dot, so it will, what will do this, that it will also duplicate the uh, delete the duplicate rows. Okay, it has been executed the duplicate rows. Now if we need to rename of any column, what we will do? Okay, if we need to rename of name with the first name, what we will do, just we will do the df is equal to df dot with column renamed. Okay, like the employee name, name with the first name or employee name, that what we will what that we will do accordingly. Okay, just df dot so what, from this one it will update the name with employee name. Simple. Okay, employee name here. The next example we will take of join. Okay, for join that we need a new data frame. Let's we will take a new data frame of country database. Okay, as and we will join with the help of department. Okay, if that we will create a new department and the us with the country, like the sales having the usa, finance is also having the france. Okay, so this type of the table, new data frame we will create, and after then we will join between those two data frames with the help of department column. Simple. Okay, so what we will do, just create a new data frame, data department is equal to, like the finance Los Angeles, marketing San Francisco, or sales San Jose. Okay, this has been come. Okay, we have the finance sales HR, like we will take the HR is here. Okay, so we have the department and the location, so it will create department.df is equal to spark create data frame will become date tab or columns. Okay, like the department.def dot so, just execute this one. Okay, so we have got the finance with Los Angeles, HR with San Francisco, sales with San Jose. Okay, so now what we will do, we will perform the join operation here between department df and the df here. Okay, okay, so what we will do, just a df underscore join, we will create a new table, a new data frame, just df dot join. Okay, department dot df df.department is equal to df.department.department. Both data frame also having the same data frame, mean department column. Okay, so we will perform the inner join here. Just perform the df.join dot show. So what it will show, what is the error? Has no attribute the department. Okay, here is a small. Yeah? So don't confuse this one. We need to, it is also having the case sensitive, so we need to perform the same name here. So you can see like the here the join between these one. Okay, Los Angeles and as per the finance. Okay, so we have covered everything is here from select whatever we have performed that we can select the columns, filter the columns, aggregate the columns, and we can also perform the join. Okay, so here we also seen that data frame are the modern approach to for the big data processing in Apache Spark. They provide a high level optimized API for working with them structured data, making them easier to use than RDD. Okay, with the PySpark example of this slide, you have learned new how to create a data frame, and with the PySpark example in this guide that you have learned how to create data frame and perform common operation like filtering, joining, and aggregating. Now you are ready to tackle big data processing task with easier. Okay, so thanks for watching. If you found this video helpful, you don't forget to give it a thumbs up and subscribe to the channel for more content like this. See you in the next video. Thank you.